Okay, so we were on the Chapter 8 Factoring and Multiplying Polynomial Study Guide. So the first question has a polynomial for us which says 14x to the third minus 7x squared plus 90x. And question number 1 asks, is this, or says, what degree is the polynomial? So remember, the degree is saying how many variables, what's the most amount of variables that each term has. So this first term, because it says x to the third, that really means x times x times x. So that has 3 variables. 7x squared is really x times x, so it has 2 variables, and obviously x is just 1. So you might get tempted to add up all the numbers and say that this is a 6th degree, but when we're looking for a degree of a polynomial, we want the largest term degree. So the largest term degree is the 3. So this is called a third degree polynomial. Or there's a shorthand way, a word you could say it's a cubic. Cubic is another word for a third degree. Question 2 says, do you have a quadratic? Well, quadratic, we didn't talk about too much, but we talked about it a little bit. A quadratic is a second degree polynomial. So right away, the answer to this is no. Because we just said that it was a third degree. To be a quadratic, you have to be a second degree. So second degree is just a shorthand or a synonym for saying a second degree polynomial. On to question 3, where we actually start doing some calculations. So we have 4ab plus 2h cubed minus 5h squared plus 17ab plus 4h cubed minus 2a. And it wants us to simplify to put together our like terms. The first thing we need to do is get rid of these parentheses. So there's a 1 in front of here. So everything in here gets multiplied by a 1, which obviously changes nothing. So it's 4ab plus 2h cubed minus 5h squared. In our second parentheses, there's a 1 in front. It multiplies everybody as well. And it also changes nothing because you're multiplying by a positive 1. And now we can combine like terms. So we see I have a 4ab, and I have another ab, and it's a positive 17ab. So if you have 4 apples and 17 apples, you would end up with 21 apples. So that's why we call it 21ab. And notice that the variables themselves don't change, just the quantity of them. Then we look for the next thing if there's anything else. We got some h cubes, which we also have over here. So we have a positive 2h cubed and a positive 4h cubed. So if we put them together, we have 6h cubes. Then we have some h squareds, but there's no other h squared, so we just bring it on down. And then we have a 2a, which there's nothing to put together, and so we bring that down here. For this question, the order does not matter. So I do not care, and that's for the whole test that you take. The order in which you write your answers does not matter to me. I just care that you get the right number and the correct variables with them. Now number 4 is a little bit different, because 4 is a combining like terms problem again, but this time it's a subtraction problem. So something unique will happen in this question. So we have 7w squared minus 2w plus 4. So what happens here is you have that 1 in front, so we distribute the 1 to all the numbers. So we have a 5w, a plus 3w squared, and a minus 9. But here's where you have to be careful. In front of here we have a 1, but it is a negative 1. So you have a negative 1 times a 7w squared, which is a negative 7w squared. You have a negative 1 times a negative 2w, which gives you a positive 2w. And then you have a negative 1 times a positive 4, which gives you a negative 4. So this was the key thing to remember, is that you were multiplying with the negative on that second parentheses. Now we look for things that we can put together. So the first thing I see is a w. Look through the rest of the problem. We have a w over here. So you have a 5 plus a 2, so that's 7 w's. Then we have a w squared. And notice that we always put the number with the symbol in front of it. We have a w squared here, but this time it's a -7 or -7. So 3 minus 7 is a -4. So we write -4w squared. And then finally, our regular numbers, a -9, -4, make a -13. And again, the order does not matter for that question. On to number 5. For number 5, we're doing multiplication. We have r minus 8 times r minus 5. You can do the double distributive property with this question, but I still see most people in class using the box method, so that's what I'm going to use. So we set up a box. The top of the box are your first two terms, so an r and a -8. The sides are your second two terms, your r and -5. And now you just do the multiplication. R times r is r squared. R times -5 is -5r. R times -8 is -8r. -5 times -8 is a +40. Now you want to combine like terms. So you have a -8r and a -5r, which is going to give you a -13r. Then you have your r squared from the beginning and your +40 at the very end. So that would be your final answer. R squared minus 13r plus 40. On to number 6. Same thing, just we made the numbers a little bit bigger. We added some more variables. So you have -6y plus 4r times 7y minus 3r. This time I'm not going to use the box. I'll do the double distributive property. So this is -6y times a 7y, which is a -42y squared. A -6y times a -3r, which is a +18ry. So this has done the distributive. Your first term, now the 4r has to do its distribution. So it's a 4r times a 7y, which is a 28ry. And it's a 4r times a -3r, which is a -12r squared. So then you look for common terms, which we have right here, the ry's. So an 18ry and a 28ry is going to make a 46ry. These are y squareds, these are r squareds, so they're not the same. So we just bring them down into the problem. And so that's our final answer. And again, the order on that one would not matter. Number 7. This time it's multiplication, but instead of the first parentheses having two terms and the second parentheses having two terms, I gave you two terms in the first, but three terms in the second. So again, you could do that distributive property, but since I did the distributive property on the last one, we'll go back to the box method for this one. Now we need to make the box a little bit bigger this time because we have more numbers. So I'm going to split mine into 2 rows and 3 columns. However, you could do 3 rows and 2 columns. It's really your choice. It's not going to affect your answer. So I have a 2x third and a 5. So 2x to the third, 5. I have a 3x squared, a -7x, and a 4. And now we just multiply. 2 times 3 is 6. X to the third, x squared is x to the fifth. -7 and 2 is -14. X to the third and x is x to the fourth. 2 and 4 is an 8. Bring that x to the third with us. 5 and 3 is a 15. Bring down the x squared. 5 and -7 is -35. Bring down the x. 5 and 4 is a 20. Now we combine like terms. And we don't have any like terms whatsoever. So we just write it as a long expression. 6x to the fifth minus 14x to the fourth plus 8x cubed plus 15x squared minus 35x plus 20. And that would be your final answer. Number 8. And I would put a star next to number 8 when you're looking over your study guide. This is the most missed question on page 1 of this test every year. This says 3d minus 9 squared. What this does not equal, And this is what a lot of people think the answer is. They think it's 9d squared plus 81, or they think it is 9d squared minus 81. Because they go, oh, well, you just square the two things on the inside. Not true. What this is saying that the inside is being multiplied by itself twice. Just like if I wrote 3 squared, that would be 3 times 3. If I do 3d minus 9 squared, that is 3d minus 9 times 3d minus 9. If you write it the long way, then all of a sudden you see that this is where you can't just simply square the two numbers and be done. We've got to go back and use the box method. So the box is the same on the sides and the top. You have a 3d minus 9 and a 3d minus 9. So 3d times 3d is 9d squared. 3d negative 9 is negative 27d. Negative 9 3d is negative 27d. Negative 9 is an 81. Now we combine like terms. We've got two sets of negative 27d. And that's where you get the negative 54d from. That probably a lot of you, not a lot, but some of you might not have had that to begin with. You still have your 9d squared and your 81, but when you do the full multiplication, you see that there actually are d terms. So when you see something being squared, write the expression twice. Don't try to take any shortcuts. We will learn a shortcut about it next chapter, but as of right now, we don't have a shortcut for it. All right, number 9, again, some multiplication. We've got 2m plus 7 times 2m minus 7. This time I'll do distributive property. 2m times 2m is 4m squared. 2m times negative 7 is negative 14m. Now we move to the 7. 7 times 2m is a positive 14m. 7 times negative 7 is a negative 49. We're going to combine like terms, which ends up being the m's in the middle. A negative 14 and a positive 14 cancel out, so you're left with 4m squared minus 49. Now on to page 2. Page 2, we have a little bit of a word problem with the graphic. So the graphic is the square, and the dimensions are 3x and x plus 2. And then you've got a smaller square in the middle, and its dimensions are 2x by x. And then there's all this shaded area that's in between the two squares. And the question says, what's the area of the shaded region? So these are like those old 5th grade geometry questions where you would figure out the area of the whole thing. So the whole area, and then you subtract the part that you took out. So it's the whole minus the white area, because we don't want that. We only want what was left over, the shaded. So to find the area of the whole figure, since it's a rectangle, you multiply them. So 3x times x plus 2 gives you the area of the entire figure. Then you're going to subtract the area of the inside figure. The inside figure is x times 2x. So once you do that, now you're back to just regular simplifying expressions. But you have to look at the figure to figure out what your area formulas were and what to multiply and what to subtract. So here we go. 3x times x is 3x squared. 3x times 2 is 6x. Negative x times 2x is negative 2x squared. Now we combine like terms. We have a 3x squared and a negative 2x squared, which gives us just x squared. The 6x has no one to go with, so it's just x squared plus 6x. And again, for example, the 5th grade problem, they would have done this. They would have said, hey, this is 5 by 8. The inside is 2 by 3. Find the area of the shaded part. So you would have done 8 times 5 minus 3 times 2. But we're not using just regular numbers, we're using expressions, and that's why we consider it an algebra problem. Now on to the new stuff of this chapter. All that stuff that we just did is technically review from September. Now comes the new stuff. So question 11, now we are factoring. And when we factor, and you can write this down on your study guide as you're looking over this, we have a checklist of what we always look for. The first thing you always look for is a GCF. Then you look for factor by grouping. Then you look for the diamond. Then you look for the big diamond. Finally, you look for the difference of squares. So I'm not going to write that down every single time looking through the study guide, but you can write it down and follow along if you need to. So our first expression is 10x squared plus 15x. So I look for a GCF first, meaning is there anything that goes into 10 as well as into 15? And there is, and the biggest number that goes into it is a 5. Then I look at x squared and x. Well, x squared is x times x, and x is just an x. So we look to see if they have any x's in common. And they do. They have one x in common. So that's what we pull out. So once you get your GCF, you need to get the insides of your parentheses. And the way we do that is you take your original expression and divide it by the GCF. So 10x squared divided by 5x is 2x. 15x divided by 5x is a 3. If you were to multiply this through, you would end up at 10x squared and 15x, which is what we wanted to simplify or factor. So that's how we can always check these problems, is actually multiply it right back through. Number 12 is a little bit more complicated because we start giving you more variables and bigger numbers. So 18x to the 7th, y to the 3rd, minus 30, x cubed, y. Again, the first rule of all factoring is to look for a GCF. So I have an 18 and a 30. There's lots of things that go into both, but the biggest, the greatest that goes into both is a 6. Now we look at the variables. The first one has x's, the second one has x's, they have them in common. The most that they have in common together is 3 of them, so we pull out x to the 3rd. Then we look at the y's, they both have y's in common. The most that they have, this one has 3 and this one has 1, the most that they have in common is just 1. So that is your GCF. So again, the shortcut rule was look for a common variable, and then you pull out the smallest exponent one. So x7, x cubed, the smallest is x cubed, because 3 is smaller than 7. Y to the 3rd, y to the 1st, the smallest exponent is a 1. So that's what you pull out. Now that's a shortcut rule if you want to use it. So now we got to figure out the insides. So we have 6x cubed y. To get your insides with the GCF, you divide by what you've just pulled out. 18 divided by 6 is 3. X to the 7th divided by x to the 3rd is x to the 4th. Y to the 3rd divided by y is y squared. Minus 30 divided by 6 is 5. X to the 3rd over x to the 3rd, they cancel. Y to the 1st over y cancels, so you're left with just a minus 5 on the inside. 13. Y squared plus 7y plus 6. So we look for a GCF. There is no GCF. So then we do factor by grouping. Well, to do factor by grouping, you have to have 4 terms. That's a must. This only has 3 terms, so it's not possible. So then the next one in our checklist was the diamond. And a diamond has to have 3 terms. So far, so good. We have 3 separate terms. And it has to be a variable squared, then a variable, and then just a number. And that's what we have, a variable squared, a variable, and then just a number. The way these work is the answer will always be 2 sets of parentheses with a binomial. You're looking for 2 numbers that will add to give you the middle, which is a 7, and multiply to give you a 6. So some of us like the graphic organizer, where we would put the add number on the bottom and the multiply number on the top. And there's only one combo that works. It's got to be a 6 and a 1, because 6 times 1 is 6, 6 plus 1 is a 7. So your two sides become the two last numbers in each binomial. The first term is always just the square root of this first term here. So the square root of y squared is a y. So it's always just going to be that letter, that variable. 14, we have a squared plus 8a minus 48. Again, we would look for a GCF, but we don't see one. Factor by grouping has to have 4 terms. We don't have it, but we do have 3 terms, and it is a squared a number, so that's where we're going to use the diamond factoring. So we're looking for something that adds to give me 8 and multiplies to give me negative 48. For those of you that like the diamond, the add is on the bottom, the multiply is on the top. So you just start going through all the number pairs that multiply to give you 48. Since I know that we have to add to get a positive and multiply to get a negative, I know that one is positive and one is negative. So I can already fill out part of my answer. It's a plus something and a minus something. So 48, the first two things that come to mind are 2 and 24. But a 2 and a 24 added together are never going to get me to an 8. So then you just keep looking through. And for some of you like to do the rainbow factoring, meaning if you start with 48, the first number that goes into 48 is a 1. So 1 times 48 would give you a 48. Then you could go to 2, a 2 and a 24. And then we go to a 3, which would be a 3 and a 16. And then you could check 4, which would be a 4 and a 12. And then we could even go further and do 6 and 8. But this gives you all of your possible combinations. So you got to see if any of those would work. And one of them does work. If we use the 12 as positive and the 4 as negative, it multiplies to give me negative 48 and adds to give me a positive 8. So a plus 12 and a minus 4. Then 15, we look for a GCF. There isn't one. Then we check for a diamond. Or we go factor by grouping, but it doesn't work because we only have 3 terms. Diamond works. We would add to get negative 12, multiply to get a positive 48. So if I'm multiplying to get a positive and adding to get a negative, it has to be 2 negative signs. So x minus something, x minus something. But here we run into a problem. You can't multiply to get 48 and add to get a negative 12. There aren't any number combos that work. And you could go back and check your rainbow factoring here, because these are all the possibilities, but none of them would add to give you a negative 12. So since this doesn't work, we don't say no solution, we use the word prime. Prime means it can only be factored using a 1, which is of no use to us, so we just write the word prime. (16), we have 2x squared plus 5x plus 3. No GCF, no factor by grouping, and it's not a diamond either. It looks like a diamond because you have an x squared, an x, and a number. But what you have is you've got this number in front of the x squared. So instead of a diamond, this is what we called in class the big diamond. And here's how the big diamond works. Because this 2 is in the front, it has a job to do. And it will always come over to the very last term and multiply it. So the 2 multiplies to 3 and it turns into a 6. So now your new diamond, the multiplication number or the number pair, we're not trying to find something that multiplies to give us a 3, but something that's going to multiply to give us a 6. But we still want to add to get a 5 because we didn't touch the add number, so that doesn't change. And so the 2 numbers that would make that work, multiply to get 6, add to get a 5, are 3 and 2. Here's where the second new step came into play. The first step was the 2 had to do a job. The second step is that you had to change this to 4 terms. So the first term stays the same. The last term of 3 also stays the same. The 2 new numbers we're going to use are the 3 and the 2, because the 3 and the 2 are going to make our 5x for us. So we write plus 2x plus 3x, and it could be the other way. You could put a 3x here and a 2x here as well. You'll get the same answer, just look a little different to start with. Now once you get to that step, you use your factor by grouping. The way factor by grouping works is you take your problem, you split it down the middle. You look at the first 2 terms only and you GCF factor it. So the GCF of these 2 terms is a 2x. The insides would have been an x plus 1. In order for factor by grouping to work, whatever you use in the first parentheses, you have to use in the second parentheses. So now you ask, can you multiply x plus 1 by something to get a 3x plus 3? And you can. You can multiply it by a 3. So now your answer, since x plus 1 is being multiplied by a 2x and it's being multiplied by a 3, you put them in parentheses, 2x and 3. 2x multiplies x plus 1. The 3 would then multiply x plus 1. So that is your answer to question 16. Question 17, we have 3x cubed minus 12x squared plus 2x minus 8. No GCF. It's not set up for diamonds because you have 4 terms. And right when we know that there's 4 terms, there's only one thing to do, and that's factor by grouping. So for factor by grouping, you take the first 2 terms, you find the GCF. So 3 and 12, that would be a 3. X cubed and x squared would be an x squared. Divide your first 2 by what you just pulled out, and you will get a, x and a minus 4. For factor by grouping to work, the second factoring has to also use an x and a minus 4. And then we see if that's possible. And it is. Because if you multiply x minus 4 by a 2, you get 2x and you get a minus 8. So then your answer is 3x squared plus 2 times x minus 4. On to 18. You have 8x squared minus 200. First step is to look for a GCF, which we do have. 8 will go into both of these terms. So you have 8x squared minus 25. And then if you circle this, you are incorrect. That is the wrong answer. And this is where we haven't had to do it yet, but you're supposed to go through the checklist. And I didn't do it for all the other questions just to save time because I knew there wasn't anything else we could do. But on this one, we can. After we do the GCF, we look for factor by grouping. You're looking at what the leftovers are. For factor by grouping, you would need 4 terms, so it can't be done. Diamond, you need 3 terms, so it can't be done. But the one thing we haven't done yet is what's called the difference of squares. In order for the difference of squares to work, it tells you what you need. You need a difference problem, meaning subtraction, which we've got. And then you need squares, meaning they're numbers that you can take the square roots of, or variables, which we have. So the way difference of squares works is you still end up with a binomial times a binomial. The first term is the square root of the first term here. So the square root of x squared is x. The second term is the square root of your second number. So the square root of 25 is a 5. Then it's always going to be the same thing. One of these is going to be addition. The other is going to be subtraction. And don't forget to bring down your 8 because it was part of your answer to begin with, so it stays part of your answer. That is what is the full final factored form of number 18. 19, we have x cubed minus 7x squared plus 12x. First step is always looking for a GCF, which we do have because they all have x's. So we pull out an x, which would then leave you with on the inside x squared minus 7x plus 12. You then look at what's left over, and you see, does factor by grouping work? No, because you need 4 terms. Does a diamond work? Possibly, because it is set up for a diamond, because you have an x squared, an x, and a number. If we were to use a diamond, you have to add to get a negative 7 and multiply to get a 12. So add negative 7, multiply 12. In this case, there are 2 numbers that will do that, a negative 4 and a negative 3. So your answer from the diamond of this is x minus 4, x minus 3, but don't forget your final answer has to have your GCF. So this one required 2 steps to factoring it correctly. On to number 20. We have 16h squared minus 81y to the 4th. So we look for a GCF. Don't have one. Factor by grouping. No, because you need 4 terms. Diamonds, you need 3. So the only last chance is the difference of squares. Difference of squares, you're looking for 2 things. You're looking for a difference question, which is what we've got. It's subtraction. And you're looking for perfect squares. We also have that because we can take these square roots. So the square root of 16h squared, square root of 16 is a 4. Square root of h squared is an h. Square root of an 81 is a 9. And the square root of y to the 4th is y to the 2nd. Because if you were to do y to the 2nd times y to the 2nd, that's really y times y times y times y, which gives you the 4 y's which we were looking for. You make 1 a plus, you make 1 a minus, and that is your final answer. Some people thought in earlier classes that this was difference of squares again because it's subtraction. And we can take the square root of 9, we can take the square root of y squared, we can take the square root of 4, but what you can't do is the square root of h. We have no idea what the square root of h is. So that's why we couldn't do difference of squares to keep it going. On to 21. This is the second most missed question every year on the test, so I would write a star next to this one as well. This is 4x squared plus 9. GCF, don't have it. Factor by grouping, no. Diamonds, no. Difference of squares, and people think, yes, it's difference of squares, but if you look at the first word, which is called difference, difference means it has to be a subtraction problem. This is addition, so you can't do anything with this. This is prime. You can't do the difference of squares because it's not a difference problem. It's a sum problem or an addition problem. For 22, we have 25h to the 3rd plus 30h squared minus 30h minus 36. We look for a GCF. We don't have one. Factor by grouping. Yes, because you have 4 terms. So we're going to split it right down the middle. And now we take the GCF of the first 2 terms, which would be a 5 and an h squared. The insides would then be 5h plus 6. Factor by grouping, if you get whatever you get in the first parentheses, you have to use in your second parentheses. So we get a 5h plus 6. Then you see if it's possible. 5 times negative 6 would give you a negative 30. And a negative 6 times a positive 6 would give you a negative 36. So factor by grouping does work. So then your first parentheses are your outside factors, which were 5h squared and a minus 6. Your second parentheses is the inside factor, which was 5h plus 6. 23 is a word problem. 23 says the area of a rectangular coffee table is t squared plus 7t minus 8. And the length is t plus 8. They want to know what is the width. Well, this is just a factoring question in disguise. To find area is the length times the width. So they've already given you t plus 8. That's the length. You've got to figure out what was the width. So this is just diamond factoring. What adds to give you a positive 7 and multiplies to give you a negative 8. That would have been a positive 8 and a negative 1. So t minus 1 was the other dimension. And finally, 24. This goes back to the first page of the study guide. That's why I put it on here twice, because it's always the thing that we struggle with, because we try to go too fast. It says 2x minus 3y squared is equal to 4x squared plus 9y squared. Because this student thinks that all you do is you just square each of these numbers. But remember, we talked about it. 2x minus 3y squared really means 2x minus 3y times 2x minus 3y. If you work that out, and I'll use a box again, 2x minus 3y, 2x minus 3y, 2x times 2x is 4x squared, 2x times negative 3y is negative 6xy, another negative 6xy, and this becomes a 9y squared. If you combine like terms, you get 4x squared, a negative 6xy and a negative 6xy make a minus 12xy. And that's what the student forgot to do. They forgot their middle term, most likely because they didn't work it out the long way. They tried to take a shortcut, which this shortcut does not work. So they forgot the minus 12xy.